For section 3.2, we are going to look at angles formed by parallel lines and transversals. So our first postulate here, corresponding angles, says that if we have two parallel lines and they're cut by a transversal, then the pairs of corresponding angles are congruent. So remember from yesterday that corresponding angles are in the same spot on a different line. So if I were to cut this picture in half right here between the parallel lines, angles 1 and angle 3 are in the top left-hand side. So those are corresponding angles. So those would be the same. Same thing for 2 and 4. They are in the top right-hand side. So those are going to be the same. 5 and 7 are in the bottom left-hand corners. So those would be congruent. And then 6 and 8 are in the bottom right-hand corners. So they would be congruent. So this postulate tells us a lot about those 8 angles. So for example 1, find each angle measure. They want us to find the measure of angles A, B, C. So where this X is. So this angle right here. So these are parallel lines. Those arrows indicate that those two lines are parallel. So this other line going opposite is a transversal. So if I cut my picture in half, this angle right here is in the same spot as that angle right there. So if that top one's 80, then our bottom one has to be 80 as well. So the measure of angle ABC is 80 degrees. And then we have to find the measure of DEF over here. Oh, can't zoom in. So DEF is this angle right here, indicated by X plus 30. Well, again, if those two lines are parallel, indicated by those arrows, we could cut these in half, and this is the top right-hand corner. So the top right-hand corner of the other section is this 2x minus 45. So we know that both of those are equal. So I can set up an equation showing that those are equal. And then I have to solve for x. So remember I told you to always get rid of the smallest one first. So we're going to minus x. 2x minus 1x would be just 1x. The minus 45 is still there, and 30 is left on this side. And then we're going to add 45. So x equals 75. Now it didn't ask us what x is, it asked us what that angle measure is. So we have to plug it back in there. We have to actually do 75 plus 30, which would be 115 degrees. So the measure of angle DEF is 115. Then we're going to look at a couple more theorems here. We have the alternate interior angles theorem. So yesterday we talked about what alternate interior angles were. Now we're introducing a theorem that shows they are the same. So interior, remember, is on the inside of your parallel lines, and alternate means on opposite sides of your transversal. So we have two pairs, we have 1 and 3, and 2 and 4 that are congruent. Alternate exterior means on the outside, but on opposite sides of the transversal. So 5 and 7 would be congruent, and 6 and 8 would be congruent. And then same side interior angles. So what that says is that they're supplementary. So they're on the same side of the transversal and they're on the interior. So angles 1 and 4 would add up to be 180, and angles 2 and 3 would add up to be 180 degrees. So we have to find the measure of angle EDF in this picture. So EDF is right here, labeled with the X. And the only other thing that we know is that this angle ABC over here is 125 degrees. So we have to determine if that is the same as 125 or if that X would be the other angle. So the transversal, both of those angles are on the outside of our parallel line, so they're exterior, and they are on opposite sides of the transversal. So that means they were alternate exterior angles. So alternate exterior angles are the same. So the measure of this angle would be 125 degrees. And we know that by the alternate exterior angle theorem. Then we have to find the measure of angle TUS in this picture. So TUS is right here, indicated by 23x. The only other thing we know is that this angle is 13x. So looking at those are the same side interior angles. They're on the same side of the transversal and they're on the inside of our parallel lines. So that theorem tells us that those two angles would add up to be 180 degrees. So I can write 13x plus 23x would be 180 degrees. So I can combine like terms, and I would get 36x equals 180. Then I have to divide both sides by 36, and I would get x equals 180 divided by 36 is 5, so x equals 5, but they asked us for 23x. That was the angle given, so then we have to do 23 times 5, and that would be 115 degrees. And then our last example here says the treble strings of a grand piano are parallel. And those are indicated here by the blue lines. Viewed from above, the bass strings from transversals to the treble strings form transversals. So the bass strings are the pink, and they are cutting through the parallel treble strings. Find x and y in our diagram. So if I look right here, I can see that this angle labeled 120 degrees right here would be the same as this one because they are corresponding angles. They're in the same position. So I know that 120 equals 25x plus 4y. Now, over here on the top, this 125 and the 25x plus 5y up there would also be equal because they are alternate. They're on opposite sides of the transversal, exterior, and they're on the outside of our two parallel lines. So I can write those two as an equation. I can write 25x plus 5y equals 125. And the other one, 25x plus 4y, is equal to 120 degrees. So if you remember back to Algebra 1 when we did systems, this now formed a system, and we can subtract. We can use that elimination form of solving systems. 25x minus 25x would be 0, so those would be gone. And then 5y minus 4y would give us 1y. And 125 minus 120 would leave us with 5. So we just found y. That was one of our answers. It said find x and y, so we found y. Now we can plug that back into one of the other equations. So if I just pick that top equation, I would have 25x plus 5 times 5, since y is 5, equals 125. You can very well plug this into the second equation. You will still get the same answer out for x. So if we simplify that, we have 25. Then I have to minus 25 from both sides. So 25x equals 100. And then my last step would be to divide by 25. And 100 divided by 25 would be 4. So x is 4 and y is 5 for that problem.